All right, here we go. So this is a quick review of sine, cosine, and tangent, how we first talked about them. This is straight up geometry that we're doing. I actually did this. I'm doing this in my geometry class 6th period, like this exact worksheet. So it's the same thing. So we need to be in degree mode whenever we're working with triangles. We need to be in degree mode. We always were in degree mode in geometry, if you remember, because we measure angles in degrees. We're looking at just right triangles today, but next class, when we talk about law of cosines and law of sines, that's how we're going to expand this for non-right triangles. We've also got our little abbreviation here, SOHCAHTOA, to remind us that sine is opposite over the hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. You could think of this too as a little bit of SAT review, because this is on SATs for sure. Who's taking the SAT in a couple weeks here? Nice. Maybe I'll be your proctor. Could be fun. No. Okay. Notice in this right triangle here we have 3 angles, A, B, and C, and they're capital letters. Notice that opposite angle A, we have lowercase a as a side length. Opposite angle B, we have lowercase b, and opposite angle C, we have lowercase c. This is our normal convention for triangles. We're going to see this a lot, so just get used to it. And we just want to remind ourselves, sine of A would be opposite over hypotenuse. That would be A over C. Cosine of A would be adjacent over hypotenuse, so that's B over C. And tangent, opposite over adjacent, would be A over B. You guys go ahead and fill out that second row. Okay, so sine B is what? B over C. Cosine B, A over C. And tangent B, B over A. Okay, notice that sine of B and cosine of A are the same thing. Sine A, cosine B are the same thing. That's always going to be the case. We think about the unit circle, like sine of 60 is 1/2. Sorry, sine of 30 is 1/2. Cosine of 60 is 1/2. Right? These values switch. We're used to them switching. Cosine of 30 is √3/2. Sine of 60 is √3/2. So those values exchange all the time. Tangent, they're reciprocals of each other. That's also always going to happen, right? The angle, the side that's opposite one angle is adjacent to the other. So it's just a different point of view. Yeah. So with these right triangles here, to find the missing values, we've got some information here. Number one, we've got a side that's 8. And we've got an angle that's 34 degrees. So finding x is going to be the easiest one. How do we find x? Mike?
So every triangle equals 180 degrees, and that square angle, that's equivalent to 90 degrees. So you add 90 and 34, and then you just subtract that from 180.
Yeah. A slightly shorter way to do that, that only works for right triangles, is the two acute angles there, they add up to 90, so we could also do 90 minus 34. That's not going to work in non-right triangles, but it does work in right triangles. Okay. So now I need to solve for A and C. So if I'm trying to solve for A, what I want to notice is, from my angle's point of view, A, we would say, is the what side? Opposite, adjacent, or hypotenuse? It's the opposite. And 8 is what? Adjacent. What uses opposite and adjacent? Tangent. So we would say tangent of 34 equals opposite over adjacent, A over 8. And then we would want to solve for A. How would we do that? No. Isolate it. How? Multiply both sides by 8. So the 8's cancel out. And we're just going to type 8 tangent 34 into the calculator. And that's going to be our answer. We're going to make sure we're in degree mode. We'll just do 3 decimals again, because YOLO. Okay. Everybody get that? Cool. So now we're going to solve for C. So what am I going to use to solve for C, sine, cosine, or tangents? We're going to use cosine, yes, because we have 8, which is the adjacent side, and we're looking for C, which is the hypotenuse. We have some options, some other options. We could do Pythagorean theorem with this number right here. We could also use sine with that number right there. Can we think of any reason why we might not want to do that? Okay, it's rounded. Yeah, it's not exact. That's one reason. And then there's another reason. If we were wrong, that would be double wrong. Exactly. Those are the 2 reasons. So we want to just use 8 and 34. We would set it up cosine 34 equals 8 over C. And now we have C on the bottom. How do we solve for it? Multiply by C, yes. Multiply C on both sides. You're right. So now we have C cosine 34 equals 8. Looks kind of weird. Cosine. How do we get C by itself now? Yeah. And divide by cosine 34. So in the calculator, we're going to type in 8 divided by cosine 34. Okay. Did we get that? Great. Do number 2. Ready, set, go. See how fast you can do it. It's a race. Yes. We're done?
Done.
A and A is opposite, so it's opposite adjacent, and then that's how he got tangent. So you do whatever side you get it, so because it's hypothesis, and then you want to find the hypotenuse and adjacent.
Okay, so we've got the two legs are missing here. We have the 50 degrees. We have the hypotenuse. We do 90 minus 50 to get x, the other angle, which is 40 degrees. To find b, because b is the opposite side of 50, and we know the hypotenuse, we're going to use sine. So I would set up my equation, sine 50 equals b over 20. Which I did, right, yeah. Multiply both sides by 20, cancel out the 20s. So b equals 20 sine 50, so that gives me 15.321. To solve for a is the adjacent side, and we also still know the hypotenuse is 20. So that's why we're going to use cosine. Our equation here would be cosine of 50 equals a over 20. Multiply both sides by 20, cancel it out. Type in 20 cosine 50 to the calculator, and we get 12.856. Question 7. Yeah, you could do that. Yeah. I mean, maybe if you found 40 incorrectly, it's obviously 40. Like that's very easy math problem to do, but that would just be something to be aware of. Yeah. Okay. Let's look at number 4. Number 4, now we are missing both angles. And we have 2 of the legs. So first of all, to find C, we would do the good old-fashioned a squared plus b squared equals c squared. We would not want to use sine, cosine, or tangent for that. We'd just use Pythagorean theorem. And we would want to simplify that if possible. In this case, it is not possible. Five squared is 25.
And the answer is 72.
No, it's 75.
Really?
I knew the answer was root 74. I got lost in the middle. Okay. To solve for x and y, so let's start with x. We have the opposite side and the adjacent side. So we would use tangent. Tangent x equals opposite over adjacent. And remember, when we're looking for the angle, so that's why we're going to use tangent inverse. So you did use tangent inverse in geometry to find angles because tangent inverse is an angle. When you use tangent inverse, it switches the x and the ratio of the sides there. And so that can just go into the calculator like that. Okay, you guys go ahead and find y. using the same method. Just use tangent.
It's the same thing with the file.
That's kind of hard to see. Okay, so a very similar process here. We use tangent. We're going to have to use tangent inverse. So it's tangent inverse of 5/7. Notice that that angle and the one that we already found do add up to 90. So it's a good way that we can check our answers.
We use inverse when we're looking for angles and not when we're looking for just sides, right?
Yes, an inverse is an angle. Yes. Okay, we're going to look at the back for like 2 minutes. So don't pack up yet. And once you're done writing that down, you can go to the back.
Hey,
No, why would we?
Okay. On the back. So these word problems are basically just getting you to draw a right triangle and then solve the same way. So there's some phrases that we're going to see. So typically people look straight ahead. Freshman boys don't do that, but most other humans do. Whenever you look up, the angle that's formed between your normal horizontal line of sight and where you're currently looking is called the angle of elevation. And then when you look down, it's the angle of depression. But notice they both use that horizontal line as one of the sides of the angle. So we're going to look at number 10, and then we'll be done. So number 10 here we have from the top of a lighthouse, 210 feet high. The angle of depression of a boat or to a boat is 27 degrees. So here's our boat. And there's our angle of depression. We're trying to find the distance from the boat to the lighthouse. Should I put the 27 degrees right here? No, I should not. The angle of depression is the angle between the horizontal line of where you would normally look and where you're currently looking. 27 degrees is going to go right there. Now, since these lines, here's even more geometry. Since these lines are parallel, that 27 degrees and this angle down here, the boat's angle of elevation, are alternate interior angles, and so they are congruent. And so we can put the 27 down there instead. And so now we would just have this right triangle. If we're trying to solve for x, we would just set up our equation like this and do a little solverino on that. And we get like 412. Okay, so you got 2 things for homework. The back of that other worksheet and the word problems.
Wait, what?
It's like 20 problems total. It's not that bad.